Welcome to the ninth and last video in the series of videos on Introduction to Swift. In this video, we will learn about protocols, generics, and access controls in Swift programming. Protocols. Protocols are used to provide a blueprint for methods, properties, or other functionality requirements. Protocols can be adopted by a class, structure, or enumeration to provide the actual implementation of those requirements. Any type that satisfies the requirements of a protocol is said to conform to that protocol. We define protocols in a very similar way to classes, structures, and enumerations. If a class has superclass and also implements some of the protocols, then class names should be listed before the protocols, and all protocols should be comma separated. The protocol doesn't specify whether the property should be a stored property or a computed property. It only specifies the required property name and type. Protocols also specify whether each property must be gettable or gettable and settable both. Property requirements are always declared as variable properties prefixed with the var keyword. Always prefix type property requirements with the static keyword when you define them in a protocol. For example, here we have defined a protocol with two variables and one functional. So class call history implements this protocol and thus is required to define the variables and functions declared in the protocol. So you can call the properties and functions of protocol defined in class by creating an instance of this class which implements the protocol and calling the properties and functions by using a dot syntax. Protocols can require specific initializers to be implemented by conforming types. You write these initializers as part of the protocol's definition in exactly the same way as for the normal initializers, but without curly braces or an initializer body. Protocols do not actually implement any functionality themselves. So, any protocol we create is a type which we can use in our code. Because protocol is a type, you can use it in many places like other types, for example, a parameter or a return type in functions, methods or initializers. You can use protocol as the type of a constant, variable or a property. Protocols can also be used in an array, dictionary or other type of containers. You can extend an existing type to adopt and conform to a new protocol even if you do not have access to the source code for that existing type. Extensions can add new properties, methods, and subscripts to an existing type and are therefore able to add any requirements that a protocol may demand. A protocol can inherit from one or more other protocols and can add further requirements on top of the requirements it inherits. The syntax for protocol inheritance is similar to that of class inheritance, but with the option to list multiple inherited protocols separated by comma. It can be useful to require a type to conform to multiple protocols at once. You can combine multiple protocols into a single requirement with a protocol composition. Protocol compositions behave like you defined a temporary local protocol that has the combined requirements of all the protocols in the composition. You can use the is and as operators to check for protocol conformance and to cast to a specific protocol. So the is operator returns true if an instance conforms to a protocol and returns false if it does not. The as with a question mark version of the downcast operator returns an optional value of the protocol's type, and this value is nil if the instance does not conform to that protocol. The as with an exclamation mark version of the downcast operator forces the downcast to that protocol type and triggers a runtime error if the downcast is not successful. For example, here we are trying to check if ch conforms to protocol phone number by using is operator. As you can see, it returns true, which means ch conforms to the protocol phone number. Generics. Generic code enables you to write flexible, reusable functions and types that can work with any type, subject to the requirements that you define. You can write code that avoids duplication. Generics are one of the most powerful features in Swift, and much of the Swift standard libraries are built with generic code. For example, Swift's arrays and dictionary types are both generic collection. You can create an array that holds integer values, or an array that holds string values, or an array for any other type that can be created in Swift. Generic functions can work with any type. The generic version of the function uses a placeholder type name instead of the actual type name such as integer, string, or double. So we have used capital T in this video as the placeholder type for generic. For example, here we have defined two swap functions, one for integer parameters and one for generic type. Swap function takes two integer type parameters and swaps them. If we try to pass string variables as parameters to this function, we'll get an error. But swap new function takes generic type parameters, thus we can pass any type as a parameter and we'll get the variable swapped, as we have done for the integer type and for the string type as well. Access control. Access control restricts access to parts of your code from code in other source files or modules. This feature enables you to hide the implementation details of your code and to specify a preferred interface through which that code can be accessed and used. Swift's access control model is based on the concept of modules and source files. Access control applied to properties, types, and functions can be referred to as entities. A module is a single unit of code distribution, a framework or an application that is built and shipped as a single unit, and that can be imported by another module using Swift's import keyword. A source file is a single Swift source code file within a module. Three different access levels are provided by Swift language. They are public, internal, and private access. Public access enables entities to be used within any source file from their defining module and also in a source file from another module that imports the defining module. You can use public access when specifying the public interface to a framework. Internal access enables entities to be used within any source file from their defining module, but not in any other source file outside of that module. You use internal access when defining a framework's internal structure. Private access restricts the use of an entity to the enclosing declaration and to extension of that declaration that are in the same file. Use private access to hide the implementation details of a specific piece of functionality when those details are used only within a single declaration. For example, here we have a class called checkaccess, which defines three functions of different access levels. Function add is private, multiply is public, and sub function is internal. Now we create an instance of this class, and when we try to call the private function, we get an error because private functions can only be called inside the class they are defined in and cannot be called outside from the class. So multiply function is public and thus can be called from anywhere. Sub function is internal and can be called only inside this file and cannot be called from another file. To make the function's return type as private, declare the function's overall access level with the private modifier. Enumerations in Swift language automatically receive the same access level for individual cases as that for an enumeration. Swift allows the user to subclass any class that can be accessed in the current access context. A subclass cannot have a higher access level than its superclass. The user is restricted from writing a public subclass for an internal superclass. Getters and setters for constants, variables, properties, and subscripts automatically receive the same access level as that of the constant, variable, and property or subscript they belong to. Custom initializers can be assigned an access level less than or equal to the type they initialize. A required initializer must have the same access level as the class it belongs to. The type of an initializer's parameters cannot be more private than the initializer's own access level. Swift does not allow the users to provide an explicit access level modifier for an extension when the user uses the extension to add protocol conformance. The default access level for each protocol requirement implementations within the extension is provided with its own protocol access level. That's it in this video, and with this video we come to an end of this series of videos on Introduction to Swift. Thanks for watching.